Rafal, how you doing?
Hey.
All right, so we're getting things set up here. We're just going to continue the broadcast. So those of you hanging out with us, awesome. Thank you very, very much. We've got a little bit of just technical, get everything up and running here for Rafal, and then I'll drop off the stream. Any questions as they come in, I will bring them over into the private chat if you want to, or I can interrupt you. It's really up to you. How do you want your flow?
I don't care. You can interrupt away. It's better this way.
All right, excellent.
Interactive is always better, man.
All right. I will drop myself off the stream though, so that they're not seeing my ugly mug and they can see you and make sure that they can see your presentation once you get it all connected up here.
All right. So, all right. Oh, that's good. I can hit the share button. Got my slides uploaded.
All right. So do the share. I will add it to the stream.
All right, how do I switch slides? I'll just hit the forward back button, I suppose, right?
Yeah, I'm guessing. Yeah.
Oh, look at that. That's easy.
Amazing. All right. So we're actually right on we got one more minute and then we're going to be able to get on there. So, if you want to grab yourself a coffee, anyone who's sitting in the chat and needs a bio break, now's your time to go get it. We are going to try to start promptly. But give you a couple minutes here just to go and get yourself all set up.
I think if I have any more coffee, you'll see me physically vibrate. So I do one of these things where I'm scheduling the episode 500 of the Down the Security Rabbit Hole podcast, and we're doing it live. So I got Rob Hansen and Arsenic and I are playing text tag back and forth, and he's like, "Hey, you haven't sent me the meeting invite for it yet." And I sent it to him. He goes, "Dude, you sent it for 5 a.m. I'm like, sorry, time zone math. I'm scheduling it for East Coast. I'm on the West Coast. I don't even know what day it is. I don't know."
Well, that's where coffee helps a little bit.
Bourbon does the rest.
That's right. All right here. So I'm just going to clear out some things on my side.
You guys recording this, right?
Yeah, it's all recording. We're going to cut and chop this all up so it'll be a lot cleaner. This banter won't be on the stream on the YouTube that we'll put it on later, but everyone who's here right now, they're seeing and hearing us, so don't say anything bad.
How's my video?
There you go. Your video's awesome. You're looking good. You're sounding good. Your presentation looks good. So I think we're going to be all set to go here. I am watching in two different screens because I got you here in the back end so I can chat with you and the stream. But I'm also on the front end live so I can see the people. We're a little delayed on the front end. So that way I can at least get questions and get them to you. But like I said, what I will be doing is I'll be dropping off once we're ready to rock here. I'm still here, but I'm just not. We had a little hiccup in the first one there where the broadcast died for just a moment, and then it.
Yeah, I saw that.
So I have no idea what happened, but I'm sure the gremlins in the wire will figure it all out. So, okay, with that in play, I think we're ready to rock and roll. If you are.
Yes, sir.
I'm not even going to introduce you. People know who you are. If not, please feel free to introduce yourself because, hey, who doesn't know the White Rabbit and who's not listening to the podcast? Come on.
I don't know. Wow, that's awesome. Thank you.
Have fun. And I'm here if you need me. But otherwise, I'm dropping off. And
all right,
go for it.
All right. Good. I think it's still morning. Good morning on the West Coast in beautiful Vancouver. How you guys doing? This is Raf. Some of you may know me by the Twitter handle, the White Rabbits. Just plug, who am I? Well, I've been around for way too long. Some of you guys have seen me present there, well, not recently, but a couple of years ago. I still have my cool socks, the pink and blacks from presenting up there. I'm coming up on episode 500 of Down the Security Rabbit Hole podcast in exactly 7 days. And so hopefully you guys will be on the live stream for that. Go find that on the LinkedIn page. Look up Down the Security Rabbit Hole podcast. I'll be there. This talk is called Chaos in Userland when the feature is the vulnerability. I have spent a lot of years in various parts and disciplines within AppSec. I claim to be a master of none of them. But this one comes from the AppSec land. I've recently had a chance to venture back into this world, primarily because there's this like magical layer 8 of the OSI model a few people talk about, and that's leadership and budget. So let's dive right in. Apparently my arrow key doesn't work, so I'll have to use my. All right, I'm gonna do this in 3 parts. First one is what's the problem. Second one is how did it get there? third is now what, right? So feel free, please ask questions in the channel. I'm sure they can interrupt me. Have no issues with that. So what is the problem? What are bad features, otherwise known as vulnerabilities? Well, I think the first question really that we have to start with the premise of is what exactly is a feature? And it can be one of many things. Features are, generally speaking, something that is required, right? So it's something that wants to be. There's two sources of them, as far as I can tell, that are generically speaking across the universe. And the first one is customer requirements. For those of you that build software or product for the customer space, customer will want something. They say, I wish it could do this or that. And somebody says, hey, they're paying for this. Let's go ahead and build it. The second option is an idea or an innovation. So you've got a bunch of people sitting around a room. Generally, these are engineers. And they go, wouldn't it be cool if? And suddenly the if thing happens. This is generally the more dangerous one, because wouldn't it be cool if typically results in fun mayhem, as you'll see in a little bit. But so let's talk about this. The second premise is what exactly is a vulnerability? Well, you guys are in InfoSec, you know what that is, but a little bit of reflection. A vulnerability really is comes down to a couple of things. It's a flaw or an error that causes weakness in the system that you can exploit potentially, right? To do bad things, or if you bear with me, things that you probably shouldn't have been able to do in the first place. And that's where this talk and that's where this conversation gets kind of fun. So what exactly is the difference between a feature and a vulnerability? Well, you'd think they were pretty obvious, except sometimes that's not so much the case. Can something be both? And sadly, the answer to that is yes, more oftentimes than you guys will probably want to admit. And in the comments in the chat windows here, if you've ever run into one of these, just, I don't know, wave or say something that lets me know. But I'm pretty sure every one of us at some point in our careers has encountered something that's hey, that's really cool, but that's awful at the same time. So I will give you a couple of examples, and you're welcome. Something. And so a couple of examples. You'll recognize some of these, and it would be really fun if you would, as I give the generic version, if you have your hands on keyboard ready, type out what it is. So the first one, remember when you could upload CSS unfettered to a web page to make cool things? Anybody remember what that was called? Anybody? There you go. Remember Tom on MySpace? Yeah, that was awesome. You know what the result of that was? Guys, remember the Sammy worm from our friend Sammy Kamkar? Yes, that was a good time. Sadly, once that happened, people sort of went, "Wait, I can do this kind of thing on all over the web," and hilarious mayhem ensued. What about JavaScripted PDFs? You think that was a customer feature, or you think that was a bunch of developers sitting around and going, "You know, it'd be really cool if." I got to tell you, I wish I was had a magical machine that I could get into that would take me to that point in time, because there's some words I'd like to have as a security practitioner. What about the one-click buy? Does anybody remember this one? This is a big deal. Close to almost a decade ago now. Anybody remember? So the one-click buy, it was the famous thing. Chris Shiflett, I think, was the discoverer of this in Amazon. And like a year goes by and they're like, it's no big deal. But you could literally buy a bunch of hidden data in a form, have somebody click a button and buy things for you and have it shipped to your house, all with no intervention. It was brilliant until it wasn't. Website file uploads. Yeah, these are a fantastic idea. Upload random code to a website, random files to a website. No big deal there, right? Every website ever that asks you for to identify yourself and has you upload a profile picture of yourself. Can you upload scripts? Can you upload very, very, very large multi-terabyte GIF files? I don't know. Try to find out. So all these, crazy thing is, all these at some point were a fantastic idea. Somebody said, would it be really cool on this boring social media page if you allow people to personalize it? We should let people personalize it. Let them do cascading style sheets inserts, because it's cool. It allows you to create flashing, marquees. It allows you to do all kinds of things. And what's the worst that could happen? Right? What's the worst that could happen? So these were all good ideas, but something along the way went wrong. So horribly, horribly wrong. Terribly wrong. And it's strange, because if you start to think about how we go from really good idea to really bad outcome, it's not a terribly long stretch of chasm to cross. And so how did some of this manifest? Okay, how did we build in vulnerabilities completely by accident? And so this is most people would say, well, this is simple, right? I mean, it's quite easy. Duh, it's the developer's fault. I mean, what kind of, insert derogatory phrase, person would do something like this? And the answer is all of them. All of you, all of us have done these things, right? We have thought a wonderful feature. We've all, well, maybe not all of us, at some point in life thought, hey, I could put my key under the mat while I'm going away for the day, and a friend of mine could come over and easily, get in. Meanwhile, the stranger that walked by that watched you do that now suddenly has a great way into your place, right? So blaming developers is fun and easy, but if you've never seen this graphic, I keep this around for all these types of talks. I'll give you a second to kind of pitch through it. Um, I like Tyler puts in, hey, let's integrate this browser with OS components to make it easier to do stuff. Yeah, awesome idea, super powerful. Somebody just, I think I just saw something about Python being integrated into the web browser to allow you to script Python in with OS commands. What's the worst that could happen? I mean, that sounds like a fantastic idea. But if you've gotten a chance to read this slide, right, it's really interesting in how you think about this. Because if you've never played that game where you sit back to back with somebody, you have your own pad and pencil, and you are asked to sketch something out by a third party, and then you turn around and you swap drawings, and you go, how the heck did you get there? And the other person goes, that's weird. Why would you draw that? That's how we got there. Okay. It's not quite that simple. It's not as simple as blame, because if you think about creative misuse, which is basically the job title of anybody that's in this industry, right? We do creative misuse. We look at how something is meant to function, and then we go, yeah, so what happens if you, and insert fun thing here. Creative misuse is a really interesting way to get from really cool feature to, oh my God, we blew up the internet in like 7 seconds. Case in point. So on one hand, we have really good intent. On the other hand, we have really bad outcome. And they say the road to hell is paved with good intentions, otherwise known as really interesting features. Okay. And if you think about some of the really bad things that have gone on that were complete accidents, like things that are put in log4j, these things that were put into the browser, things that were put into applications, where somebody said, this is a really good idea. And yeah, it's probably a really good idea, but it's also a terrible, terrible vulnerability. It's going to allow bad things to happen. And both of those can be true at the same time. So do you guys know, if you know what's going on right now with Netflix, they're having this issue where there's thousands of people sharing profiles, and potentially tens of thousands or hundreds of thousands, if you believe them. So Netflix profiles, it used to be you logged into Netflix and it was, you had watched and it kept track of you and all that. And they went, what if there's like multiple people living in the house? Jack said, I was promised no one would mention log4j. Sorry, wrong talk. Netflix had these profiles in that you could, like your kids could have their own profiles that would recommend things they like, your significant other, which was awesome until people went, hey, that's cool. I can give like 7 of my friends profiles and my password, and we can all watch what we want. It'll keep track of all our things. So the feature is multiple profiles. What a fantastic idea, a great innovation. And it's, by the way, it has been copied on just about, like, Disney's done it, Amazon's done it, Paramount's done it. You can tell how many streaming services I signed up for, but all of them have done it at some point. Now, now the outcome of that is happy family of users, and yay, congratulations, but also password sharing. Ergo, Netflix has an issue because one person pays, like 12 people can watch. Yeah, that tends to be a revenue problem. So the developer says, hey, look, this is working as intended, right? You guys wanted us to create profiles. We created profiles. They work. Did they work as the spec sheet said? And the answer is absolutely. And then security people come along and go, seriously, this is a problem, right? Because it does create, well, not even security at that point. Now, if you're talking next Netflix example, but revenue people come along. But yes, this creates an issue for us. So here we have two things that can be true at the same time. It can both be sunny and raining at the same time. You can have a great feature that's also hilariously exploitable and bad for the company at the same time. Yes, that would be great. The world would be a better place if those really cool ideas were at least optional, documented, and always disabled by default. Tyler, good luck with life. If that is your philosophy, I would love that too. It's not the parallel universe I live in, but maybe it's at some point. So let's think about how we address this. What is the root cause, right? How in the world did we get there? Whose fault is it? Who do I blame? Where do I go? So, all right, there's a couple of these. The first one is requirements in isolation. And that means that somebody went through and took some requirements and didn't talk to anybody. Early on in my career, I'm not going to tell you when, but it was a long time ago. It was pre-2000. I was perfectly aware of several of these types of situations where a bunch of project people got together and said, hey, customer wants us to do this. What do you guys think? And they went, yeah, that sounds like a great idea. We should do it in this, and this way, add this feature, and move along. Nobody in security was ever invited to those things. Arguably in 2022, still aren't. But that was we'll do security on this later, right? Oh, we'll have security give this a look later. Well, the problem with that is some things are fundamentally broken and you can't security later them. So, you know, if you get to this level of catastrophic failure where you're like, look, you put yourself into this, there's nothing I can do to get you out. I can just watch the train wreck in slow motion as this kid is the pain he's feeling. So think about Flash. If you guys listen to the podcast way back, I had Brad Arkin on the show. Golly, it's been a hot minute, but he talked about when his team took over at Adobe at the time, Flash, and SWF player was awesome. You could do so many cool things with it, and believe me, people did. I did an entire talk on people doing authentication within Flash. That was fun. But he's like, look, the code had been written, the functions were in the plugin, and they're like, okay, now you go secure this. He's like, you're accepting unvalidated input as part of the app. You're allowing this, and this, and this. He goes, unless you change that, I can't do it. They're like, no, that's done. You just go, do the security thing. He's like, all right. So what I had to do was we had to do a giant sandbox for this, hot mess of code. And that's the situations y'all get into, and it is not fun. So once the requirement is built, security can be completely, or at least nearly, impossible. Or for those of you that know the reference, inconceivable. So it is exciting that way. Number two, how does this happen? Well, development in isolation. So we've had requirements in isolation with nobody's input. This is development in isolation. This is probably a little further down the road at the point where things still could be salvaged, but probably aren't. And so back in my vendor days when I worked for HP, we had a fantastic unit that provided customers with functional testing software, performance testing software, and we even bundled security testing software. Well, we challenged people to ask, does it function? Does it perform? And is it secure? They got 2 out of 3 right. Guess which one they didn't do? So the reality is, right, development tends to get done. Developers worry about function and performance. And it's really difficult, as an aside, as a security professional, come in and say, we used to think about it this way. Well, what are all the things it's not supposed to do, right? If you remember the way AppSec used to work, we'd get a scanner and we'd say, okay, I'm going to scan it and it's going to, anything that it kicks out is bad. Like, yeah, but if a third party's writing this, tell me all, like the developers and the project managers are telling me all the things that it should do. Here's the list. Tell me all the things that the software is not supposed to do. You're like, basically anything except for these things in this list. And it turns out that's a hard thing, all right? So these would become problems. Security testing done later, and much to my chagrin, you could still do security testing later, but not without the actual product spec, not without what is it supposed to be doing, what are the actual requirements, does this app really require me to upload arbitrarily any file, or did the customer say, hey, I want to upload pictures? And could it be pictures of a specific type, JPEG, GIF, and could it be pictures of a specific size between 2 meg and 10 meg? Like, what's the use case for uploading 4 petabytes of a GIF file besides hilarity, right? So having specs when you're doing security testing is super important. If you've got nothing else, at that point you should be able to do that. So you're basically asking your security team to go find all the things that this thing's not supposed to do, and the answer is that's a pretty large space of stuff. My favorite topic: pattern-based security testing. I am hoping that most of us are through this dark forest and into the light. But if we're not, this is not this type of vulnerability class, right? These abusive function. This is not SQL injection and cross-site scripting where you can develop patterns for it, write it into an app, and say go. This requires human creativity because scan tools won't find it. And this is where we get that creative misuse again, right? We sit in that room and go, all right, I've run the scanner. It's kicked out some SQL injections, some cross-site scripting, easy to fix. We'll get the developers to do that. Now, what are all the things that I could do with this that I'm not supposed to do? And that is a really tough thing because it's a lot of space. And generally speaking, you're probably not allowed to just go randomly beat up applications and use cases. But we're agile. That's great. Good luck. Agile just means you can do it faster. But creative misuse is both a good thing and a bad thing in this discussion. So implementation ambiguity. I don't like this one, number 4 here. But what it means to me is I've asked for something ambiguous and you've implemented something ambiguous, and the result is it does either not enough or way too much, but at least it meets the base of what I wanted. So let me show you. Hey, anybody been on these calls? Well, hey, the firewall is blocking this app. Okay, it's not working. Something's not working. It's got to be the firewall. Well, it's always the firewall. Let me break it to you. And somebody says, well, okay, fine. What do you need to make this thing work? What ports, what protocols, what IP addresses, what's the application? And the person says, I don't know, just enable any. And yeah, I mean, and that's basically what our reaction is. But it's true. What's really interesting is ambiguous requirements people tend to err on the side of overly cautious. They build in way more than they should, because you figure, okay, if somebody says, going back to that tree swing, if somebody says, I want a bridge over this stream, you may think that you may want it to be enclosed. You may want it to be well leveled. And what really somebody's asking for is a 2x4 so they can walk across it, right? But if you overbuild, odds are you can A, charge more, B, it looks really cool, and C, somewhere in that overbuild, you've met your customer requirement. So that's why it gets there. So do you guys remember this nightmare, right? When somebody you're on a call or doing support, and somebody says, "Well, we just need to open all the ports because it just has to work. We'll figure this out, how to lock it down later." And the answer is no, you won't. Nobody ever does. It's never going to happen that way. I'm sorry. Number 5 is technical limitations, and some of these are real. Some of them are contrived, and by that I mean maybe even circumstantial. So we need to upload photos. I've been in one of these conversations where um, a project needed to upload photos, technical schematics, whatever, into an application, and the developers were like, "Yeah, okay, I'll allow file uploads." And in reviewing of the spec, I thought to myself, well, the customer request says photo uploads. The IT app spec says file uploads. Those are not the same. One encompasses the other. And then you think, okay, what is it that I could do if I could upload arbitrary files to a web server at any time? Like, holy crap, right? Hello, malware. So thinking about this, the developer can't potentially differentiate file types. Okay, so your developer's either not good, or the 18-year-old or the 15-year-old in Russia that you've hired isn't quite up to the latest whatever on whatever framework you're using. And so rather than photo uploads, they do file uploads. They don't check sizes. They don't even check the header to make sure it actually is a JPEG file. If it's named .jpeg, good enough for me. So the reality is these can be technical limitations. So developers enables any file upload, and well, you guys know how that goes, right? All right. So hopefully, let me give you a second to kind of flip through these comments. Yes, static code analysis helps in some things, but it's unfortunately, that doesn't unfortunately solve that problem. So let's talk about how we can reduce and decrease the risks here, because the reality is it's not going to go away. Blame does not fix this. It doesn't matter how many project managers you get fired. It doesn't matter how many developers get tongue lashed and yelled at and reprimanded. It doesn't matter how many times you make the front page of the New York Times for being overly crazy. It's going to happen again, right? So it will guaranteed happen again. Somebody is going to fall into one of those 5 categories that I just went through on the why, and we're going to get to it. It's going to happen again. So you've got 3 possibilities, okay? And I think the 3 possibilities, I think they're very realistic, and I'm going to give them to you in order. I think you should do them all, but if you can't, start at least as far back into the requirements phase as you possibly can. And if you can't, then I don't know what to tell you. So number 1, at requirements time, critical requirements review. All right, this doesn't require any particular expertise in any particular development language. It doesn't even require security people. It just requires somebody to do a critical review of the requirements you're being asked to do. Okay, the customer says upload all files. Can we restrict that somehow? Like, is that really necessary? Do I really have to go pull in arbitrary file types? Ask these questions. Ask lots of questions. And I tell people, act like sometimes in these things, act like a 5-year-old does. Just keep saying why. That needs to happen. Why? Because this. Why? Because this. Why? You go, do you know what you're saying right now? And eventually, let people get to the conclusion of, if I continue down this requirement path, if I allow this to happen, bad things are going to happen. Look, guys, I know you want people to upload, arbitrary files into this website that you're creating because you want them to be creative. but maybe stop to think that this could create a wormable condition, or our application could become the source of a ransomware outbreak and distribution method for somebody else. Is that really something you want? Can we do something that could limit this, right? Do that what if analysis. So what happens if? Hey, have you guys thought about what if, right? And get into that mindset of asking questions. Because if you don't, I know who will, and they probably don't work for you. Start thinking about misuse case. This is where I guess the creativity of this community really impresses me, because I think that we are so creative by default. Sometimes it's a little scary, because I've seen projects that I would otherwise think are fairly well locked down. The requirements are pretty good, and somebody goes, "Hey, have you thought about whatever?" And my brain goes, "Oh my God, I would have never thought that. I can't. What kind of person would do that?" And you go, "Wow, that's terrible. I need to fix that." So it's interesting. It's really interesting how some of the misuse cases apply and appear in these issues. So downscope broad requirements. If something says I need all ports open on our firewall, all ports open on all these hosts, yeah, no, you don't. Like, tell me what you really want to do, like the Spice Girls song. Tell me what you want, what you really, really want. Yeah, I know it's a drawback, but I think I think trying to downscope what people want, because everybody's going to tell you they want everything. You go, yeah, but that's not possible. What's the least amount of function that will accomplish the requirement that then I can secure, that I can think about securely? Evil user stories. I like that, Chris. That's a good idea. Abuse cases, evil user stories. That's a good idea. All right. Number 2 is development and testing. I think that if you're going to go have a little bit of fun, have it during development and testing phases. You're going to be able to get a lot of really, really interesting results if you allow people to really get involved in development and testing phases. But then again, we've been saying that for literally decades now. So test requirements, test the actual code itself. Go in and look at what it is. Go look at all the things that they think it does, right? So the way I write I do this mentally is I have a whiteboard, and I look at the requirements, like what did the customer or the person writing the requirements intend, and then I say what is the function, and then I have on the right side of the board, like, what is all the things that it could actually do that this side has never thought about. And that's a lot of fun, because what you oftentimes find is like 5 requirements on this side, and by the time you get to the other side of your board, you're running out of space. And then you get to take a picture of that, send it to the what I would do is I'd write the good things in blue and the bad things in red, and I would send it to the project managers, and I go, all right, I did my analysis on your requirements. Here's what I think. And oftentimes they would look at it and go, oh, cool, it can do so many other, why is all that red stuff there? Right. And you go, well, what do we do about that? And that sparks conversation. So testing code is a big idea, but testing it before it becomes code, even when you're looking at functions, because when you're like, there's some of these modules that get used, the developer will use it for one function within a module that has 40 other functions in it. What do the other 40 do? Can we add them? Can we have fun with them? Can we do really, really bad things with them? The answer is probably yes. Testing downstream functions. So, okay, think about it this way. You are integrating multiple applications, and your app allows file uploads. They don't check for the header, and so even though it says photos only, but so you create a .jpeg file with a bunch of CSS in it. Why not? Because you can, or whatever you want to stuff inside there, Python, whatever, and it goes downstream. And that downstream, one application passed to another, and somewhere downstream, that app decides it's going to process that file. It looks at it and says, That's not a JPEG. That's code. I'm going to run that code for you. It didn't affect you, but it affected something downstream. So think about the downstream functions that happen. And that's a really impressive and important way to look at it, because it forces you to look at the entire ecosystem of what you're testing and what you're developing rather than a single function. Because just because that single function can't be exploited by the bad data you insert doesn't mean the 17 other things that take advantage of that data as a secondary consumer of that data, that bit, that input, doesn't mean that they can't be badly influenced and broken. So think about that one. Security test functionality. So security test the functionality that's in these applications, and what I mean by that is, sure, stuff. The wrong characters in there. My professor back in college, when my first assignment in MIPS risk, yes, because this was a long time ago, asked us to write a calculator in assembly, and I was pretty impressed with myself. I actually got it to run. It was cool. I could do 5 plus 5, 10 plus 10, 27 times 8, and whatever it was. And I saw he asked for volunteers. Who got this code running, and who's excited about it? I'm so excited. I raised my hand. He pops it up on the projector, and he says, "All right, it runs." He goes, "Now let's try some functions." He did 3 plus 3, 6. I'm like, yes. He does 9 times 7. Yes. A plus Q. I'm like, wait, why would you core dump? I was like, wait, why would you do that? He goes, why not? Because you didn't check your inputs. And I said, well, okay, but it does all the things you told me to. If you put in numbers, it works, but if you don't put in numbers, it doesn't work. Like, why would anybody do that? And that class, more than anything, got me thinking about this industry in the late 90s, middle late 90s, because it got me thinking about, all right, but I filled the requirements, but I didn't create limitations on those requirements. And so people could stuff all kinds of things into my calculator function. And yeah, bad things happen. And so that's a good area to think about, really, when you're talking about security testing functionality. Allow open-ended security testing. So open-ended security testing is a lot of fun. What I mean by that is don't put restrictions on your security testers. When you're testing a function, an application, a kiosk, whatever, right? Whatever the thing is, generally it's code of some kind. But don't limit people. Allow them to get creative. Allow them to creatively misuse or be the evil user, and then have them come back to you with all the crazy things they could do that your developers and your project management team and your customer would go, why would anybody do that? And oh my gosh, the outcome is not good, right? So, if you can deposit or if you can withdraw a negative number from your checking account, and it allows you to do that. Like, this is an old trick way back. We used to play these when we'd write code in school. We'd write ATM types of apps, and if you could write one that would allow negative inputs, so it would allow you to give yourself money. Why would anybody do that? Well, very simple. I like money. So open-ended security testing and allowing people to get creative is super important. Don't limit your testers, which means this isn't going to be something that, you can't give it to security on Friday afternoon and say, hey, it's going live on Monday. Just go and give it a check. No, that's not how this works. You have to be involved as much throughout the process. Yeah, Dana, I think that core dump all the things would be a good shirt. Or just one segfault core dumped. I think that would just be, that would just be a great shirt to have, because people would look at you funny, except for those that are old as us, and then they'd laugh. So, let people get creative. Let people go blow things up. And I'm sorry, but sometimes it's going to require the system to go up in flames, because it's better that you find that than somebody else. Don't artificially limit your security testing. Don't say, you can only use these inputs. Don't do anything bad. which is how we get to, well, I've already deployed this. Don't do anything bad that could harm the app, but go ahead and security test it. That's nonsense. That doesn't work. All right, so post-deployment, there's things you can do. For example, designing for failure. This is something we started doing about 15 years ago. Not everybody's gotten that memo, but I hear it's getting passed around quite a bit. Designing for failure is interesting because you say, okay, people are going to put all kinds of crazy things into this text field or try to upload all kinds of crazy files. What happens when they get one past the development team? What happens when they get one past us? This is an opportunity for basically being able to log all the things or as many things as you can find necessary, and then look at the things that you should see, and look at the things that are happening and say, do these relatively close to match up? And this is how you get behavioral profiling on applications, on humans, on anything. Because if we know what it's supposed to do and it's not doing that, something could be very, very wrong, right? Like with that fish kissing picture earlier. So designing for failure is important. Implementing compensating controls is also another thing, right? What you want to do is limit the impact of poor requirements, and as much as you can, limit the impact of when something breaks. This is why the concept of zero trust has gained so much traction, and people have taken it so seriously, is because when not if, but when something catastrophically blows up in your environment, how do you keep it from taking down the entire company, right? This is why cloud service providers have pushed this resiliency concept. So if US East VA 1 goes boom, the whole world doesn't stop, except that it sometimes does, quite often in a big way. But let's get past Amazon. This stuff does happen, right? So how do you design for minimizing impact, increasing resiliency, and when bad things, misuse happens, what do you do about it? That's an important question. It's an important topic to discuss. Log and analyze is what I'm getting at, right? Log application functions, log the application. When you're doing use case testing, profile the application, profile the thing. How much CPU is it using? How many queries does it do on average per, how many times does it query the database per user per minute? How many rows on average does it return? We had a long time ago, had a really cool case where an application got profiled using the performance management suite of tools. So they knew the nominal CPU, they knew peak times and low periods of the application. They knew how many users it should have. They knew how many connections each user opened, how many queries they issued, how many rows were on average returned. And so when the security team saw a possible SQL injection attack, they looked back to the app team, and the app team said, well, let's see. One user has 25x the number of typical queries against a database. It's returning 1,000x the row count, and the CPU is 90% busier than it normally is. Yeah, that's a problem, probably, right? So being able to look at these things in multiple dimensions, not in just our security dimension, hugely important. And it allows you to monitor for misuse. Guys, this is really tough. And I'm not going to say there's a magic unicorn out there that's going to do it. There's been apps out there that have said, we do behavioral profiling and understand how things go. The reality is apps are complex, environments are complex, and sometimes your applications will do completely bonkers things just because that's the way they were designed, and they were going to do completely bonkers things. But try your best to monitor for misuse. All right, and I'll give you guys some of my parting thoughts here. This is a common issue. This is not something that you're just facing, I'm just facing. It's happening everywhere all the time. It happens to major companies, the really good companies like Netflix and Amazon. It happens to tiny companies. It happens to just about everybody. Bad features are everywhere, and there is absolutely no magic fix, okay? That's the sad part. There's not a magic fix, but you can have fun trying. You're going to need some sort of strategy. And that's a good thing, right? Review your requirements with your teams, get involved in the design as much as possible, and employ that creativity that we're also always excited about in testing. Ask lots of questions. It's the human nature. And every once in a while, add 3+Q and see what happens. If you get the result I got, which was a site fault core dump, and then find less terrible alternatives. Look, if you know you're I've got a requirement. This is not a joke. I have a requirement right now from a customer that I'm working with, where they have an application that has, I'm not kidding, FTP open to the internet because some of their devices, let's say, have to upload data and they're very old. And this is the only way they do it. They're like, well, we have to allow FTP. And I about fell out of my chair when they said that, because I was like, am I still in 2022? Like, what day is it? What year is it? What planet am I on? That FTP is still a thing. It is. I promise. It still happens. And so we had to come up with compensating controls, less terrible alternatives. All right, if that's got to happen, cool. Can we limit where it comes from? Can we limit how big the files are? Can we limit put only, not get? Like, what can we do here? And so find less terrible alternatives. All of them might be terrible, but some of them have to be less terrible than others. And that's it for me. I will happy to. I've been kind of trying to read as I went along. Fuzz or fault inject all the things. Yes, Chris, that's a great way to do it if you get the opportunity to. Thanks for listening, guys. Tune into the Down to Security Rabbit Hole podcast when you get a chance. And this is where to find me. And boy, that's a white on white. That's a good graphic there. But that's how to find me. I'm on Twitter. Go check out the podcast. Check out Lightstream. It's where I'm at every day. And that's my LinkedIn stuff. Thanks. Questions, comments, Dana?
Awesome talk. Lots of great chat. And thank you so much for answering a lot of the chatter as it was happening. It always makes it even more fun when it's quite dynamic. No questions have come in. This is your chance. You got them here. Anyone out there that wants to, put it in the Q&A panel, and we'll make sure that he answers it for you if he can. Great talk, though.
Yeah,
I love the points about the telemetry management and looking for anomalies becomes easier if you understand what the app's telemetry is supposed to be like, right? It makes the security team's job much easier too.
Well, but that's the thing, is that oftentimes, and this is kind of the change that's happening in the industry. I think, DevOps, by the way, DevSecOps, not a thing. That DevOps has, when security gets involved, has helped us with is we get a peek at the application telemetry, not just the security telemetry, because SQL injection or application attacks don't always present themselves as really nice rules for snort or whatever thing you're using to identify. Sometimes they get to the point where one of the developers goes, well, that's weird. That's not supposed to happen. And whereas they would do that, you'd go, oh God, I know what that is, right? But these are two silos of data, two silos of alerts that very rarely cross paths. And it's a challenge for us. And that's where, badness hides, right? Is in that intersection where in the gray space we don't have access to.
I think it's interesting too that when security and the app teams get together and they start understanding how the applications are supposed to function, they can look for anomalies a little better that way. But the flip side is security and the app team can get together to start providing mechanisms for understanding misuse and looking for it. So an example is, you can do a lot with deception and detecting for things like having URLs in a robots.txt that are not valid, that are easy to monitor, to understand and get early warning of what potentially could be going wrong, right? It's hard for developers to think like attackers, though, but when they start understanding what those methodologies are, they can start plumbing in things. So like when you're talking about, SQL injection and all that, hey, a good person's not going to be firing SQL map at the system. They're actually going to delay that and slow it down. You're not going to catch it through your normal query patterns. Now, I'm not saying that won't happen, because there's always some idiot that thinks that they're the hacker wanting to use SQL map. But in the end, the point of being able to understand, but is it makes sense for them to be accessing those views, or that this is where the app team has to be able to get with the security team to be able to tell them, this is how our apps are supposed to function. Here's what we're supposed to be doing. And if the security team can help educate them on, well, here's what malfeasance might look like, they can start plumbing that in to being able to understand and communicate what logs are important, what telemetry is important, what information to watch for, right?
Yeah, and look, I know it's going to give you guys some of you guys PTSD, but let me just bring up Log4j for a second. That is functionality legitimately somebody looked at and said, we want this. A group of people said, yes, let's add this into the code. And they did. They tested it to make sure that it worked.
Yep.
And somehow we didn't realize, holy crap, look what you can do with this, until like, what, was it a year or a couple years later? I've lost track of this now, but it's like this was, it was a great idea in the use case. It was also a great idea in the misuse case, but just nobody looked at like, hey, what happens if you,
But you can always argue for things like, why don't we have egress filters on those servers as well? Like, why should there be a JNDI, even a thing going outbound or inbound on a web server that's not needing it? If it's something that's a requirement, it should be part of an engineering change order, part of the change management, that you're opening a port. And here is why. And here's why this is described as an important behavioral change to how this app's going to work. But very few people set up their servers to actually support egress filtering the right way to block, because they're just trying to make it work. Right. And that becomes part of the problem. So.
Well, and I mean, look, I think this is just what happens when we look at we look at functionality we want to add. And look, this is the Spectre, when the processor bug was another perfect example of this, where a bunch of engineers sat around and said, holy crap, we can achieve an extra 20-25% performance improvement if we do this. I guarantee you somebody said, yeah, but you know what? Somebody could figure this out and do X. And they went, yeah, but what are the odds? And they went, right, arguably really low. And then the what if statement came, and like, you know what? I bet we can get ahead of our competitor if we do this. The risk is small. Let's go do it. And then like 20 years later, somebody went, oh my gosh, I can find a way to exploit this under these 17 correct conditions with my hand on the keyboard, my gun to the admin's head. It's like, okay, great. Meanwhile, Intel's like, well, we got 20 years of market share out of this. Sweet. Was that a vulnerability? Was that the most brilliant like risk calculation ever? I don't know. I would bet with the Intel folks, frankly. But it was a vulnerability.
Yep. It was.
I mean, Chris, you're right. These trade-offs are trade-offs people make, but there's a difference between that kind of calculated trade-off and sure, let's just allow people to, I've seen developers do this over and over and over again, where the requirement is upload photo into your profile. By the time it makes into the tech spec, it says upload files into the application. You're like, those are not the same. What happened between here and here, right? And it's because the person that gave the customer request and the technical person did not see eye to eye. They did not speak the same language. It was a close enough, good enough. No, it wasn't. No, it wasn't. Somebody has to review that and go, yeah, these two things, not the same.
Well, and that's the benefit of things like threat modeling, because it gives you the ability to start creating that security debt in the backlog, so it's understood. These are the things that we're exposing ourselves to, and then it gets that alignment, because most PMs are being remunerated on expansion and growth, and so at the end of the day, they're not thinking about the aspect. They want usability over security at any day. Not that they're trying to be malfeasant; they just don't know any better. And so they'll spec it out as being, I want to upload a profile picture. But by the time that's turned into something the developer understands, who's not thinking about security in that right, it's not that they're trying to be lazy or that. They're just trying to put it into a user story that makes sense. But the threat model should catch that, because someone should be questioning that and saying, hey, wait a minute. If we're uploading a file, could they just not upload a web shell? Like, hey, what about that, right? Like, simple examples, but you get the point.
Yeah, that web shell example, and that's a brilliant one, because something that should have never happened.
No.
And yet it's a brilliant example of functionality gone horribly wrong.
Yeah.
Like somewhere there was a requirement to upload something, and then suddenly we're like, yeah, sure, why not? Code, no problem, why not? You're like, wait, what? Yeah, there's so many examples of admin functionality, and COVID exposed us to a bunch of this where we didn't have the right controls, and so suddenly employees need to work from home meant put a bunch of RDP open out to the world with nothing front ending it and allow it from anywhere with no authentication before you hit RDP, and you're like, what the hell happened there?
Yeah, and those machines that we're using at home that typically aren't corporate managed, which your son's using
don't
to
even,
play your next, they're playing games, and the
Oh.
next thing you know, it becomes the pivot point into the organization, right?
Listen, the CEO takes the laptop home because his kid has to go to school on that same laptop. Maybe not the CEO, maybe the admin, maybe the engineer, maybe the who knows, or the janitor, whatever. But that corporate laptop, maybe it is a corporate laptop that went home, but suddenly now their kid has to go to school from home, and they don't have another device, and suddenly they're using that device to browse Facebook, play games, and go to school, and that device has then got corporate secrets on it. Good luck protecting that. I don't care who you are. You're going to lose that battle every time if you don't compensating controls, logging, and misuse identification. And I mean, that's it. That's it.
Cool. Well, we have 5 minutes left, people. If you got any questions, please ask them in the chat window or in the Q&A panel. This is your last chance. If not, there's his links there. Make sure you go check out the podcast. Awesome.
Coming up on 500 episodes, Dana.
There's too many. There's just too many.
11. We're on the 11th year. I cannot believe I got to 11 years. September will be the 11-year anniversary of the show, and I'm just sitting here thinking, how the hell did I get here? Where did 10 years go?
Well, kudos to you. I couldn't do that. Oh, look at that. We got 5 minutes left.
I can't remember when was the 2017, 2018 when I was up there. We all ended up having sushi afterwards. That's all I remember.
Yeah, what was it? Yeah, 2017. I think it was. That was the first year we had the nice socks. So
yeah, the red and pink.
Yeah,
that
I'm
super
wearing
soft
mine right
gray
now.
T-shirt. Nice. Well, thanks to you guys that listen. That's awesome.
All right, I think this about ends it out. Then, if there's no more questions, we will be having lunch for an hour, so 12:30 to 1:30 Pacific. For those that aren't in the West Coast, I think we're going to keep the recording here running, so you don't have to do anything. You can just drop off when you want to, and you can come back. Check out the sessions on the website if you haven't already seen them. With that in play, you feel free to sit and chat in the stage or go back to the main event chat if you want to. But we're out of here. Thank you so much for an awesome talk.
Thanks, you guys. Great being here.
And we're still live, but you're welcome to chat, man. Like, thanks. You did awesome.
Nah, it's always fun. It's always fun. I'm getting back to it. I've got 2 this week here in LA tomorrow, on the beach in Santa Monica, which is no offense, but better than Vancouver at this point. You guys got snow still or what?
Snow? No, we don't have snow. Just a little rain.
Hey, Josh. Good seeing you in here. Yeah, I think I'm going to be in Vegas. Details are still a little shoddy, but we'll see. The RSA Black Hat train is going to be real interesting. So anyway, yeah, guys, if you get a chance, go sign in to listen to that podcast. That's 500 is going to be awesome. Yes, Josh, I've been to Vancouver. It's cold. I remember the last time. So the last time I was in Vancouver, I was there for Palo Alto's Ignite, And I can't remember who I got on an airplane with, but I got to sit shotgun, and we went over the bay and out. We did a cruise out. I have some of the best video and photos I've ever seen. It's been awesome. Nothing quite like buzzing a mountaintop where you could, I swear, if I stuck my hand out the window and leaned down, I could have hit the snow. It's not cold. It's awesome. Tomato, tomato. I like 70 degrees. All right, guys, I'm going to drop off. Thanks for having me. Dana, cheers. Thanks, everybody.
Later.